Hello, welcome to everyone. Let's see the problem related to domain and range of the functions. These problems are from the GCSE syllabus, but it's also suitable for all boards of examinations because maths is the same in all sorts of syllabuses. Okay. Okay, let's go to the question. Yeah, the first question. The function f of x is defined as f of x equal to 14 minus 3x. Then domain is given as p less than or equal to x less than 8. The range of f of x is given as negative change to 30.5. So we have to work out the value of p. Okay. Can you understand the question? They are provided the range and they are provided with the upper bound of domain, but we have to find the lower bound of domain for the function 14 minus 3x. Okay? Okay, let's start. What can we do? We can change this question to the inequality problem. Just substitute the function value. F of x is 14 minus 3x. Just we can solve this for x. Okay? Let me solve. Yeah. First of all, we have to eliminate 14 from the middle. So we can subtract 14 on both sides. What would be the answer? Minus 24 less than or equal to minus 3x 16.5. Then we can throw the inequality multiplied by minus 1. When we have subtracted, when we have multiplied with minus 1, the inequality changes. Less than or equal to inequality changes to greater than or equality. Greater than or equal to inequality changes into less than or equal to inequality. That is by the property a less than or equal to b implies minus a greater than or equal to minus b. Okay. For example, let's take an example. 1 less than or less than 2. We know that 1 less than 2. Yes. Then minus 2 was, what about minus 2? Minus 2 was less than minus 1. Can you see the inequality changes? Yes. Okay. Let's go to the problem. Then we have to eliminate 3 from 3x. So minus 16.5 over 3 less than or equal to x less than or equal to 24 by 3. Then this is minus 5.5 less than or equal to x less than or equal to 8. So here instead of p, we have minus 5.5. So answer p is equal to minus 5.5. Okay, let's go to the next problem. The g of x is given as x cube minus 5 and domain is provided. We have to find the range. How can we find the range? Yes, let's come. We have to make x into g of x. So for that what we have to do? Initially the function is x cube minus 5. So we can cube this inequality. So minus 2 rise to the power of inequality with 3. Okay. X cube less than or equal to 3 cube. Minus 2 times minus 2 times minus 2 is minus 8. X cube. 3 3s are 9, 9 3s are 27. Then the g of x is x cube minus 5. So we have to subtract 5 on both the sides. Minus 8 minus 5 x cube minus 5 27 minus 5. So minus 13 x cube minus 5 less than or equal to 22. Am I right? Yes. Then, so let's write the x cube minus 5 as g of x. This is the range. Okay. Okay. Shall we move on to next question? Yeah. Here a quadratic equation is provided. We have to find the range. Domain is for every values of x. So initially what we can do, we can distribute them using distributive property. We can multiply and write them in the standard form. So x squared, then 3 times x and plus 1 time x, this is 4 times x, and 1 time 3 is 3. Okay. Then what can we do? We can write it in the vertex form. So we can add the 1 and subtract 1. X squared plus 4x plus 4, sorry, plus 3 plus 1 minus 1. So this combined makes 4, and this is combined as x plus 4 the x plus 2 the whole square minus 1. Okay. Now how can we know the maximum value? The maximum value can be by this value. So the range is minus 1 comma infinity. How it is minus 1 comma infinity? It is a positive sign. Its positive sign means upper parabola. Okay. For this upper parabola, and then is negative 1 comma infinity. How can we find the range? The vertexes here is minus 2 comma minus 1. Wait a minute. Let's write clearly. The range is negative 1 comma minus 1. So what would be the range? This would be the maximum value or minimum value. Here the minimum, here as a coefficient is positive, then it is must be the parabolic upwards. So minus 1 should be the minimum value, and all the above values should be in range. Okay, then let's go to the next problem. F of x is equal to square root of x plus 1. Square root of x plus 1. Then we have to find the range. So we know that square root equation is always defined only on x greater than or equal to 0. So for an easy way at x equal to 0, we can find the f of x value. That is f of 0 equal to square root of 1, which is equal to 1. So all the above value after 1 should be in the range. How can we say that? Just we can find it is whether less than 1 or greater than 1. Just we can substitute x equal to 1, that is root 2. Root 2 is 1.732 approximately, which is greater than 1. So it is an increasing function. By this way, we can find some values. It is equal to 2, which is equal to 1. So this is an increasing function. So square root of x plus 1 is increasing function. As it is increasing function, and the minimum value is 1, it is defined from 1 to infinity. Sorry, it takes the values from 1 to infinity. So the range is closed interval 1 comma infinity. Okay. In this session, we have learned about first problem as domain, and second problem as range, third is range, and fourth is range. Okay. Then third problem is related to parabolic curve, and fourth problem is related to square root curve. Thank you. Bye bye.